Hello everyone. Today we are going to discuss about the number system. So already we learned class 6, 7th, 8th about the number system. This year we are going to learn the real number system. First we will find out how many types of the number system. So we know that one is a real, another one is a imaginary. First this is a real number system, real number system, another one is a imaginary number system, imaginary number system. So how can you differentiate both the things? If any value, so if you are finding the square root, so that is positive means that is called real number. So your square root value is negative means that is your imaginary number system. So your imaginary numbers, we can say that that is a complex number. So complex number we are denoted by capital C. So this imaginary number we will learn deeply about your class 11. So this year we are going to deal with only real number. So real number we are denoted always by capital R. Then your real number we can split it in the two forms. So first one is a rational. First one is your rational number. Second one is your irrational. Irrational number. Rational number we are denoted by capital Q. Okay. So already we learned in 7th and 8th standard in rational numbers. So what is a rational number? Rational number is nothing but if we are writing P by Q format, if P by Q where Q, P and Q are integers and your Q not equal to 0, then we can say that your P by Q is called rational number. So what about the irrational number? Irrational is nothing but if we can't write in the form of P by Q, that is called irrational number. We can see some example for irrational number. What are the irrational number? Root 2, root over prime value. So root over all the prime value, root 2, root 3, root 5, root 7 are multiple of two different prime numbers, root over 15 or root over 21. These all are called irrational numbers. So this year we are going to deal both the things. First we will properly learn about the rational number system. Rational number, it is containing a 3 number system. First one, natural number. Natural number. So natural number we are denoted by capital N. So why we are saying as a natural number? So whenever we are starts with counting, naturally we are counting with 1, 2, 3, 4. That is why it is called natural number. Natural number starts with 1, 2, 3 up to infinite, still going on. Then second one is whole number. Whole number we are denoted by capital W. Whole number we are denoted by capital number W. So whole number additionally we are having one element, that is nothing but your 0. 0, 1, 2, 3 up to still you are infinite. Then third one is your integer. So integer we are denoted by capital Z. So your integer is having 0, plus or minus 1, plus or minus 2, plus or minus 3 up to plus or minus infinity. So you are having a both whole number and negative natural numbers. Both are containing your integers. Okay. Second, one thing we want to know about these things. So imaginary number we are saying as a complex number, that is why we are using the notation C. Here real numbers, that is why we are using the notation R. So rational number we are using Q. Why we are using the notation Q? So P by Q, quotient we are having. So that is why we are denoted by Q here. The next we will come here, natural number. It is starts with n. That is why we are using the notation capital N. Whole number, it is starts with w. That is why we are using the whole notation w. But integer, it is starting with n, but we are using the notation z. Why we are using the notation z? Because of already the notation I is having for, already we learn in 8th standard in algebraic lesson. So why, where we are using the I is called identity element. So that is why we want to give any alternative simple. That is why they are taken from a word Zaglin. It is came from German word. See, it came from German word. It means to count. So that is why Zaglin, it is starts with z. That is why we are using the notation as a z. Okay. So easily we can understand this number system using a one box. Easily we can understand with the usage of one figure. So this is your real number. So real number we are denoted by R. So that two boxes we can split. First one is your irrational number. Irrational number. Then second one is your rational number. Rational number we are denoted by Q. The whole thing is what? Rational number. So rational number we can write in the form of P by Q. Then inside we draw one box. This is your integer. Integer we can write in the form of Z. So inside what you are having? Another box, that is nothing but your whole number. Then inside you are having another box, that is nothing but your natural number. Natural number, it is starts with 1, 2, 3 up to infinite. Whole number, what about the whole number? We are having 0 plus 1, 2 up to infinite. What about Z? So we are having 1 to infinite. Additionally we are having negative natural numbers, that is nothing but minus 1, minus 2, minus 3 up to infinite. So this is your integer. What about the rational number? Rational number we are having P by Q format. All such things we can write in the form of P by Q. So P by Q, P and Q are integer, your Q should not be 0. Why your Q should not be 0? Your Q is 0 means what will we get? So anything divided by 0, so that is a not defined. That is why your Q should not be 0. So if you are easily understand all the real number system using this figure. Co-prime number. So co-prime means what? Co means it is 2. So in a rational number, P and Q have no common factor, other than 1. Then it is called, your P and Q is called co-prime number. That is P and Q are called co-prime number. So in simple example we can see that. So 1 divided by 2. So what is the common factor of 1 and 2? Your P and Q. So both you are having common factor only 1. So 1 divided by 3. So both you are having a common factor here 1. So what about 2 divided by 3? So the common factor is 1. So clearly we can write your 2 and 3 are co-prime number. So now we will see one example here. So true or false example. So the form are, if following are the following statements true or false? True or false? So first part, what is the first question? Every whole number is a natural number. Every whole number is a natural number. Natural number. The next question, every integer is a rational number. Is a rational number. Then third one, every rational number is an integer. Every rational number is an integer. So we will see here. First one, what is the first question? Every whole number is a natural number. Whole number starts with 0, 1, 2, 3. So what about the natural number? 1, 2, 3. So clearly we can say that, so whole number we are having extra one element 0, but natural number does not having that element 0. So we can conclude here this statement is a wrong statement because of what is a true statement here. Every natural number is a whole number, unless otherwise this case is false. Every whole number is a natural number is a false statement here. So simply we can say that because of first one what will come here, natural number. Second one only we will get a whole number. That is why every natural number system is a whole number, but whole number is not a natural number system. Every whole number is not a natural number system. What about the second one? Every integer is a rational number. Whole number, after that we are having a integer, after that you are having a rational number. So we can clearly conclude here, every integer is a rational number. Because of integers you are having minus infinity to positive infinity of your numbers, 0 plus or minus 1 plus or minus 2 up to plus or minus infinity. But rational number you are having p by q format. Simple example, minus 5 is your integer, minus 5 divided by 1. So this is an integer, but minus 5 divided by 1 is what? Your rational number. So we can conclude here, every integer is a rational number. This is a true statement. What about the third one? So this is a converse part. Every integer is a rational number, but every rational number is not an integer. Because of this simple example we can given. So one rational number we are taking as a 5 by 3. Is it a 5 by 3 is it possible to get an integer? That is not at all possible. So clearly we can conclude here, every rational is not an integer. This is a false statement only. Now, the next example. So find rational number between 2 and 3. So this one we want to find the rational number between, find the how many rational number. This is an important role playing here. 5 rational number we want to find in between 2 and 3. First we want to choose the denominator. So what we are going to multiply. If they are given 5 means we want to add plus 1. So 5 plus n plus 1. So what will we get? N is nothing but how many rational number we want to find. 5 plus 1. So 5 plus 1 is 6 So anything, if you want to find a 6 rational number, so n plus 1, 6 plus 1, 7 you will get. If you want to find 3 rational number, 3 plus 1, you will get 4. So what we want to again, so 6 you are getting. So 6 you are going to multiply numerator and denominator by your 2. So what will we get? 2 multiply 6 by 6. So what will we get here? 12 divided by 6. Again, what is the next number? 3. So you are multiplying numerator and denominator by 6. What will we get? 3 into 6. You will get 18 divided by 6. So in between, what are the numbers you are having here? So 12 and 18, what are the numbers in between you are having? 11 divided by 6, 12 divided by 6, sorry, 13 divided by 6, 14 divided by 6, 15 divided by 6, 17 divided by 6, and 17 divided by 6. How many numbers you are having? 5 numbers you are having. If you want to find a 6th number means, so 6 plus 1, so you will get a 7. So you are going to multiply numerator and denominator by 7. So finally you will get the 6 numbers. So these are the, so therefore this is your required answer. So therefore the 5 rational number between 5 rational number between 2 and 3 are 13 by 6, 13 by 6, 14 by 6, 15 by 6, 16 by 6 and 17 by 6. So here we can conclude one thing here. So in between any two rational number we can find an infinite rational number. Here 2 and 3 is your rational number. We found the 5 rational number. If they are asking 6 means 6 plus 1, 7 things. So the same procedure, finally you will get a 6 rational number. Same thing it is applicable for your n. It is depends upon n. So n is infinite means you will get an infinite number. So you can get one note. So you will get one note. There are infinitely many rational numbers. Infinitely many rational numbers between any two rational number. So finally we can conclude this note here. So this is your rational number. The next one we are going to learn about the irrational number. So already little bit I tell about the definition of irrational number. So if you are writing anything P by Q format means that is a rational number. So we can't write in the form of P by Q means that is called irrational number. So a number that denoted any alphabet. Here I am denoting as S. S is called irrational if it cannot be written as P by Q form. So what about your P and Q? P and where P and Q are your integer, your Q not equal to 0. P and Q are integer, but Q not equal to 0. So if any number you can write in the form of P by Q means that is a rational number. So if we can't write in the form of P by Q means that is called irrational number. So we will see some example here. So any root over prime number, so root 2, root 3, root 5, root 7, root over prime number and root over multiple of the prime numbers, that is called irrational number. Then another one beauty of the mathematics, pi is an irrational number. Where we are using a pi here, so we are finding the any area or any curve. Wherever curve comes means we will use the pi because of, so in a circle, so one constant we are using here, so that is nothing but your pi. Find the area of the circle or find the perimeter of the circle. So one basic constant we are using that, so that is nothing but your pi. Pi is also an irrational number, but we are writing pi is equal to 20 by 22 divided by 7. That is not accuracy equal, that is a approximate. Wherever we are writing pi is they are putting this symbol only, so that is a approximately equal to 22 by 7, but that is not equal to 22 by 7 because of, if you are writing anything in the form of p by q means that is a rational number, so that is why they are denoting the symbol like this is here. It is an approximation value, not an equal value. So pi is an irrational number. So or any non-terminating value. Simple example 0.1, 0, 1, 0, 0, 1, 0, 0, 0, 1. So this is called irrational numbers. So these things how we can represent in a number line, that is a very important one. So one example we can see easily you can understand. How can we represent in a number line? So one example. So any value root 2 or root 3 or root 5 we can take it. Here we will take root 3. So locate root 3 on the number line. How can we locate in the number line? If we know the one concept of Pythagoras formula, easily we can locate here. So first we want to draw a one line, straight line. So take a 1 point as 0, that is your origin. So take 0, 1, 2. Okay, this is enough. So what is the Pythagoras theorem? Where we are going to apply the Pythagoras theorem? It is only applicable in the right angled triangle. What is the definition of right angled triangle? One angle should be 90 degree. One angle should be 90 degree. So what about other two angles? That is automatically complementary angle. This is called right angled triangle. So this is a B, C. So this is all A, B, C are vertex here. So what is the hypotenuse here? Hypotenuse is nothing but opposite angle of your 90 degree. This is your 90 degree. What is the opposite side here? This is your hypotenuse. So these are other two sides. So what is the definition of what is the theorem of Pythagoras theorem? So that is nothing but hypotenuse square. So what is your hypotenuse? AC. So a hypotenuse square is equal to sum of the square of the other two sides. What are the other two sides? AB and BC. So sum of the squares. So AB square plus BC square. This is the concept of Pythagoras theorem. This one we are going to implement here. So here 0. So I am taking 1 is a 1 unit here. So here what is the distance here? The distance is 1 centimeter or 1 unit you can use here. So first I want to draw a perpendicular line for your measurement 1. I want to draw a perpendicular line here. So next thing, same 1 unit. So I use a 1 compass to place it here, your this point, and cut it up an arc. That arc is nothing but your 1 unit radius. That radius is 1 unit. So what will we get here? Here also 1, here also 1. So this is what angle? This is what triangle? Right angle triangle. This is your 90 degree. So we will come here. So this is 1. This is also 1 unit. So what about this your hypotenuse? How can you find here? Here you can use this is your A, this is your B, this is your C. So what will we get here? AC square is equal to, AC square is nothing but your hypotenuse is equal to 1 square plus 1 square. So AC square is equal to 1 plus 1, it is nothing but 2. So AC is equal to, both sides you are taking as a square root, what will be, both sides you are taking as a square root, what will we get? AC is equal to root over 2. So clearly we can say that this distance, so here you take, this is a A point, this is your point B. So what about the distance of OB? That is nothing but root over 2. Then how we can locate this distance in this line, your number, real line? So use your compass, you place it your compass as O, then you take the radius as a OB. So OB is nothing but, that is the value of root 2. So you place it your O, take as a radius as a OB, so you cut it one R here. So this is your, you can take P. This your OP is what? Root over 2. So what is the distance of OP? The OP distance is what? Root over 2. But what we want to locate? Root over 3. So next, that is the same procedure we are going to use here. One side is root over 2. So this is your another point B. So we want to draw a perpendicular line here. Using your protractor, we can draw the perpendicular line here. So take same, your radius as a 1 centimeter. Use your compass, take 1 centimeter as your radius. You place it in your B. You cut it one arc here. So what will we get? Here you will get 1. So if you join O and this C, O and C, what is your O and C? Same procedure we are going to follow here. So what is the procedure here? So in a right angle triangle, one angle is root 2, and one side is root 2, another side is 1. What about the hypotenuse? How can we find here? Hypotenuse square is equal to root 2 square plus 1 square. What is the root 2 square? Root 2 into root 2, you will get 2. 2 plus 1. So 2 plus 1 is nothing but your 3. So hypotenuse square is 3. So taking both sides on square root, what will we get? Root over 3. What is your hypotenuse value? Root over 3. So what is the distance of this one? Your distance of OC is root over 3. So you use your compass, you place it in O, so take the radius as OC and you draw one arc. So it is cutting this line. This is you take as a Q. This is P, this is Q. So what about the distance OQ? The distance OQ is nothing but root over 3. Your OQ is what? That is root over